So this section is all about rotations, which is just another way to just say that there's a turn of some sort. Like you're rotating or you're turning around a certain point. So what we're going to be looking at is how to draw an image or a figure under a rotation. So with a rotation, there's always a definition of what you're rotating around. And in this case, we're going to call it point P, which is the center of a rotation. Every point that's on the original figure will be the same distance from the center of rotation than any other point on the new figure, which makes sense. If you're just rotating something, you're not changing the shape or size, you're just changing its placement. So it's another rigid transformation. All of the angles with the vertex P formed by the point and its image have the same measure. And this is what's called the angle of rotation. So if you take and turn something, even say this paper, 90 degrees, every point or anything that's on it is 90 degrees away from its original placement. Some of the rules that are written here, these are for things around the origin, which is the point 0, 0. That is where the x and the y axis intersect. And so we'll be using these rules to help us do a 90-degree rotation counterclockwise. That means against the clock. So in other words, when we're going counterclockwise, we're going this direction. 180-degree rotation, notice that it's not either counterclockwise or clockwise because you end up at the same point whether you go clockwise or counterclockwise. A 270-degree rotation counterclockwise is following this rule. And of course, 360 is where you end up right back where you were. So the points would be exactly the same. So in the first example we have here, we have this quadrilateral ABCD, and we're going to rotate it 270 degrees counterclockwise about the origin. Now remember, the origin is right here. So what that means is we're going to take this figure and spin it 270 degrees. Now 270 degrees is, what would we say, 3/4 of a turn. So if we're saying that this over here is 0, this would be 90 degrees, 180, 270. So we're going to take and turn it 3/4 of a turn. So almost a full turn, but not quite. So more than just 180 degrees, which is changing the opposite direction. We're going to go over here to 270. So the first thing I would recommend you do is you list out the points for each of the points on the quadrilateral. So I'll start here with A. A has the coordinates of 0, 2. B has the coordinates of 1, 4. C has the coordinates of 4, 2. And D has the coordinates of, what is that, 3, 1. So these are the 4 points of our quadrilateral. Now if we look up here for our rule, to do a 270-degree rotation counterclockwise means that we have to take each point, x, y, and switch it so that the new x is our old y, and our new y is the opposite of the original x. So our rule then is, take each point, we're going to make the new x will be our old y, and our new y will be the opposite of the x. So I'll make a list over here. My new A prime is my point A. So this is my x, this is my y. So the first part of it will be what was my y, which in this case is 2. And then my new y is the opposite of my original x, and the opposite of 0 is 0. To find B prime, same process. Keep our y, which is 4, and the opposite of our x, which is -1. Our C prime, keep our y, which is 2, and the opposite of our x, which is -4. And our D prime, keep our y, which is 1, and the opposite of our x, which is -3. I'll take a second and go ahead and graph those points. I take and use my protractor and connect it as best I can. So now, does that look like this original figure has been spun around the origin 270 degrees? Well, there's one way to check that out. You can take your pencil and draw a ray from the origin, and I'm just going to choose point A. And then I'm going to do the same thing through A prime. This is kind of nice because it is right on the axis. Now, if I were to take and measure this angle, what would it be? Well, a full turn is 360, so I know that from here to here is 90. So if I take 360 and subtract 90, I know that this whole turn here is 270 degrees, because 360 minus my 90 makes 270. Now I could do the same thing for each point. So if I were to take now and draw a ray from, let's see if this will make a difference. Use a different color. The origin to B, and then I do the same thing from the origin to B prime. If I take and measure now that angle that I just created, it should be 90 degrees, and it sure enough is. We're here at 0, 0 all the way up here to there is 90. This is at 90 degrees, which means what's left is 270, so it definitely is a turn of 270 degrees counterclockwise. Now notice that this 270 degrees rotation counterclockwise is the same as going 90 degrees clockwise. Clockwise means like the hands of a clock, they go in this direction. So a 270 degree rotation counterclockwise is the same as a 90 degree rotation clockwise. And you could keep doing that for all 4 points and see that every point is that same angle measurement from the origin. You could also measure the distance from the origin to the point, and it should be the same. So if we were to measure that length, it looks to be like 2.3 centimeters. You can measure it from here to here, and it is also 2.3 centimeters. So there's that premise with what we started here, that every point and its image are the same distance from the center of rotation, which is true. All right, so let's go ahead and let's try part B. We're going to take triangle KLM and we will rotate it 180 degrees. So when we rotate this, what quadrant do you think it's going to be in? 180 degrees is a half turn. So if we take this and we turn it half, it's now going to be somewhere up here in quadrant 2. So I'm going to go ahead and list out my points for K. K is here, it's at 2, -1. L is at 4, -1. And M is at 1, -4. So by using my rule that's up here, 180 degree rotation, either clockwise or counterclockwise, however you want to think about it, is I'm going to take the opposite of the X and the opposite of the Y. So that means for every point here, I want to take my original XY, I'm going to take the opposite of the X and the opposite of the Y. So my K prime then is going to be the opposite of 2 is -2. The opposite of -1 is +1. L prime. What's the opposite of 4? -4. What's the opposite of -1? +1. M prime. Opposite of 1? -1. Opposite of -4? +4. So once again, we're using just the rule that we have here. We're taking the opposite of our X and the opposite of our Y. Go ahead and plot those. Use your protractor to connect them. Now if you happen to have your patty paper with you, you could take and just verify that this is a 180-degree turn around the origin. I don't really have in my patty paper here at home, but I'm just going to show you that just by looking at, say, if I connect the origin and M, and if I look here at M and M prime, it is definitely 180 degrees. And you could do that for each of the points here. You could see that from the origin to K and the origin to K prime is 180 degrees, and the same thing for L. So we definitely have a 180-degree turn, whether we go counterclockwise or whether we go clockwise. Either way, 180-degree turn will end up here in quadrant 2. Now just to refresh your memory, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. I think that'll come up in your homework, so that's why I want to make sure that you talk about it. Alright, next one. Triangle PQR, we're going to rotate at 90 degrees. So 90 degrees counterclockwise is the assumption, and that's usually denoted by the CC for counterclockwise. So the rule for that, if you look back up at the top, is that we are going to take each point and we are going to take the opposite of the Y, but keep the X. So 90 degrees is going to take our new y, X will become the opposite of our Y, and our new Y is our previous X. So we have our points P, Q, R. So I want you to go ahead and write down what those positions are. This is really good practice to make sure that you can read the coordinates on a graph. Coordinate plane, I should say. You always read your X and then your Y. It's like a map. You're starting from the origin and you're telling it how far to go over on your X and then how far to go on the Y. So to get to point R, I start at the origin, I go over 4 on my X, and then it says down 3 on my Y, so no negative. Now using our rule that we have here, we're going to take each X, Y, and our new point is going to be the opposite of the Y and then the X. So our P prime then says take your new X is your old Y, but the opposite, and keep your X. Our Q prime is the opposite of our Y, but keep the X. And our R prime is the opposite of the Y, so it'd be positive 3, but keep your X. 4. And then plot it, and let's see what happens. So we'll have negative 1, 2. Q is negative 1, 4. And R is 3, 4. Now, does it look like you just held your pencil here and took this thing and spun it that way, 90 degrees? Sure enough. And we can take and use our protractor and just verify that from P to the origin is the same as is 90 degrees as from the origin to P prime. So if I take and draw those points, I drew the ray from the origin through point P prime and the origin through P. Take my protractor and just verify that the angle is 90 degrees. And it sure enough is. So we have 90 degrees counterclockwise. Alright, I'm going to let you try this last one. So take a minute, try it out, and we'll see what happens. You can go ahead and pause the video. So this is what the shape should be after it's transformed. We have our points D, which is -3, 1, should be transformed to the point D prime, which is 1, 3. E, which is -1, -1, should be transformed to the point E prime, which is -1, 1. F, which was -1, -4, should be transformed to the point -4, 1. And G, which was -3, -3, down here, should be transformed to the point -3, 3. Again, you're using your 270-degree rule, which we used in part A. It's keeping your Y, but taking the opposite of your X for your new Y point. And again, you've got your turn. Remember, 270 degrees counterclockwise, so it's going this way. 3/4 of a turn, almost a full turn. Now the last part we have here is on here on the back page, and we're going to talk about finding the angle of rotation and the direction. So very similar to how we just did on the front page, you look at a figure. The first thing you do is you look to see where the point is down here. We have our point A, B, C, D figure, which is a rectangle, and it's over here. So we are definitely going in a counterclockwise manner, and I have no idea what the angle measure will be. So take your protractor and start first by angle P going through point A. Now remember, you're going to have to use your protractor to measure it, so you could make your sides long enough so that you can measure it later. So if I take now and measure using my protractor that angle, I have that it is about, let's see, starting at 0, 75, 76, 77 degrees. So I have a 76-degree counterclockwise turn. I did this the other day. I got 80 degrees, so maybe it's in how I drew it. Looks like I'm off a little bit there. So I'm going to try point C. C is a little bit not in the line here. So I'm just going to check my measurement. C through point P, and then C here through P. If I measure angle C, P, C prime, yeah, that one is 80. So it was all probably because I drew that one a little funky. So we have an 80 degrees counterclockwise turn. So starting here, and we are going this direction, 80 degrees. All right, so why don't you try that on part B. Remember, you're going to start putting your ruler on point P and picking a point you want to start with, whether you want any point here, as long as whatever you choose, say you choose K, then you have to choose K prime. If you choose N, you have to choose N prime. As long as you have a point in its image or a pre-image point in the image point. So go ahead and try that. Just pause the video. So I chose point K, and I'm just drawing my line to point K, making sure that I have enough length for using my protractor. Take and look at the protractor, and this is 70 degrees. Now notice that when you look at your points, we've got K to K prime, so we're moving in either this direction, which is a 70 degrees clockwise, or if we go this direction, we would have to take 360 minus the 70 degrees, which leaves us with 290 degrees counterclockwise. So however you want to think about it, if you're going this direction, it's clockwise 70 degrees, or going in the other direction, it is 290 degrees counterclockwise. And then, last but not least, why don't you try this one, point C, or problem C. We have a triangle, SRQ, and triangle S prime, R prime, Q prime. So we could either go this direction, which is counterclockwise, or we could go this direction, which is clockwise. Now, the easiest way to measure with your protractor, of course, is to do the clockwise turn, because that should be less than 180. So why don't you go ahead and try that out. So when I did my drawing here, I chose point S and did my raise, used my protractor, and I got 134 degrees clockwise turn going this direction. Or if you take 360 and you subtract 134, it is a 226 counterclockwise turn. So one of the things you'll need for your homework today is to make sure that you have a protractor. And so maybe you want to go through and do all the problems in the worksheet that requires a protractor. Maybe do those first, just so you have all the supplies. Or if you have your protractor at home, then of course you can do the problems in order. So good luck. Remember, if you have any questions, you can always ask the person next to you. You can also go online and look at the videos from Professor Berger, maybe go through some of the lessons. You're also welcome to go and review this video. I'll put it on Remind. So if you signed up for Remind, this video will be there too.